Hello again and welcome to part 2 of the review and take apart of the Telescope Service TS65 Quad. Now, as I explained in the first part of this review, the TS65 when it was first introduced had a slight problem in some cases, not all cases, and it was to do with pinch errors. Now, a lot of people don't know what pinch errors are, and there can be, there's sort of a few variations there. In particular with the TS65s, it was predominantly when they were used in very low temperatures, sort of anything below -6, and there's a reason for that. Now, what I'm going to do is I'm going to take the scope to pieces, show you what pinch error is, and explain it a little bit better, and also show you how to get around it, because a lot of people think pinch errors are it's sort of the spawn of the devil and can't be shifted, and it's a major fault, and it's actually not, and it's not even the fault of the manufacturer in a lot of cases, and that I'll explain to you as well. The thing is, with any solid object, if you put pressure in certain places, you will get stress lines in that particular object. Doesn't matter whether it's a piece of steel or a piece of glass or even something as flexible as a CD, which if you put too much pressure on it, obviously you can see bends and warps. But even just a little bit of pressure in a sort of squeezing situation will introduce microscopic stress lines within that item. And it can actually be shown up with, you know, certain sorts of special cameras and stuff. But in a telescope, it sort of shows up in your star images. Now, you can also get pinch errors in a reflector, and normally it's due to the mirror clips, which hold the primary mirror in place, being too tight. As I've explained in a previous video, you actually should not tighten the retaining clips on your primary. You should be able to slip a thin piece of paper in between the clip and the mirror. If you do get pinch errors on a Newtonian, 9 times out of 10 they actually appear as a triangle. Your stars will start to be sort of triangular shaped, and the reason being that obviously there's 3 clips in a triangular fashion, and the stresses are going in a triangular fashion across the mirror. Obviously you just loosen your mirror clips and that cures it, and you know that's basically the end of it. Now, there are websites online where you can look just for pinch error images. You know, there's various ways that it sort of presents itself. Generally in a refractor, what it does is you will get little spikes maybe on one side of the star. It just looks a little bit spiky, it's not quite round, and there's just, you can tell there's just something not right. And again, like I said, if you look on the internet and find pinched optics images, and there are, like I said, a few of them about, then you know you'll be able to compare to your own images. So let's just have a look at this TS65 and take it apart and show you what the insides are like, and explain a little bit more about why it happens, this pinching. Firstly, what you do with your TS is remove the lens cap, and on the flexible dew shield, grip the black section and unscrew the white section like so. Eventually it'll come off. Once you've got that off, you can actually start to see now a section of what we call the lens element, which is this part. And again, simply unscrew it. Place your scope off to one side. And let's just take a look at this. Now, there is also a retaining ring on this scope that you need to unscrew, like so. Now, in a refractor, if I give you a look at that, I don't know if you'll be able to see or not, but there is actually a thread on the inside of this cell, of the lens cell, and there is a ring that is that threads on the inside of the lens cell. So what we have is, on this side we have a lip. However many lenses are used in the lens cell, you know, usually 2, it will be a lens, then it will be a spacer, and then the other lens will be stacked on top, and then the threaded ring will be screwed on the top of that. Now, if that threaded ring is screwed in there too tight, it's starting to put stress on the glass itself, which is what your pinch errors are. So what you would do in that situation is simply get down to the lens cell level like this, just take a fingernail, usually, just loosen off that ring, I don't know again if you can see that ring in there, but then what you do is, what I like to do is actually just rattle it a little bit just to make sure that those lenses are bedded in properly, and then tighten the ring up just using a fingernail. And what you're doing is you're feeling until you just make contact, and maybe just back it off ever so slightly. Now once you've got that lens cell at the right tightness, a slight rattle is perfectly acceptable. Like that, there's no problem with that whatsoever. Now the thing is that this isn't necessarily a manufacturing problem. It can be manufactured and assembled perfectly well in the factory. What a lot of people fail to understand is that in a factory they manufacture however many hundreds of telescopes that they do, and they get put in the boxes, and then they get put on pallets, and then they're taken to the warehouse and probably up and down on a forklift truck a couple of times and stacked there, and they go through different temperature variations, and then the wagon comes along and picks up the pallets from the manufacturer and loads them into containers that maybe get loaded onto ships and carted across the sea from China or wherever, and they're rocking about, and there's just all that movement involved in that. You know, they go in wagons and the wagon drives from here to there, and all that vibration and movement, it's like anything else. Because this thread isn't a tight thread, you will get in some cases where they will self-tighten, or even the opposite, they will undo. A prime example is the wheel nuts on your car. If you have a car and you go to change a wheel, sometimes you can't even move the wheel nuts because they've tightened up so much, and it's just the inherent vibration of driving your car. It just happens, basically. 9 times out of 10 that will cure it for you completely. So as I said, pinch error isn't a major problem. Now because this is a quad, there's actually more elements in here, and what we do for that is again just grip the white tube, grip the focuser section and unscrew. Now in this case, because it's a correcting element, it's actually quite an extreme curved lens. There we go with the focuser off. Now then, again, you will see that we've got this black ring. This is actually the element for the corrector. So again, unscrew. And now you can see that correcting element in there, and again that is held in by a threaded ring. Now what you do have to be careful with on this particular model is that the curvature on that lens is very extreme. If you've got big fat pobby fingers, you know, hands like a bunch of bananas, you may struggle to get a fingernail to that threaded ring without making contact with the lens, which is not what you want really. Now one thing you could use is 2 matchsticks. Just place the lens element on your knee, take 2 matchsticks and just place those in the grooves of that threaded ring, and you can see that I'm just managing to move that one quite easily with a single matchstick. Now once again, wait until you feel the little bit of resistance and then back it off a little bit, and again you may get a slight rattle. It's not a problem, a slight rattle's fine. Remember, when we're talking about reflectors, you can slip a piece of paper between the mirror clips and the mirror. There's that much movement in a reflector's mirror. Now the thing is that pinch errors can obviously have an effect in different temperatures. You can get a scope that works perfectly fine at temperatures above 0. Once you start getting below 0, different metals, in fact all sort of different solids contract and expand in temperature, and different products or different materials expand and contract at different rates, which is why you start to get pinch errors. And really that's about it for this one. It's just, you know, I wanted to explain about pinch errors and explain about the TS65 that I've now totally taken to pieces. What I would advise, once you've done this, if you feel it necessary to do it, get your blower that you should have anyway. You should have one of the puffer blowers, and just give everything a good blowing out to make sure that you've got no debris in there when you start to put it back together again, because you've been disturbing threads and everything. And obviously you just put it back together the opposite way to the way that you took it apart. What you do have to be careful of is that some of the threads on these are very, very fine, and it's very easy to cross thread them, so just take your time with it and be gentle with it. And that's about it for this one, and I hope it's just, you know, helped you out a little bit. And once again, thanks for watching.